Okay, we're going to resume again, and it's asking for total inductive reactance here. Now we've got a couple of options. We could do each individual coil, add them together, or we could add the individual coils together and then apply the formula 2 pi FL to that. That sounds a lot easier to me, and we've got all the same units, which are millihenries. So let's go ahead and come up with our total inductive reactance of, our total inductance of 60 millihenries. I got that simply by adding 30 plus 20 plus 10. So pretty easy math there. So now let's get the x of L of that, which is 2 times pi times F a little readable, times L. So let's come down here. 2 times pi times 15 kilohertz times 60 millihenries. Again, we know this kilo, this milli, we're basically multiplying by 1,000 here, we're dividing by 1,000 here. They're going to offset each other, so it's as if they are not in the equation any longer. So I can just do straight math. I like it when I can just do straight math. Save some steps, so it's clear. So let's say 2 times pi times 15 times 60, and we arrive at 5,654 ohms. If we divide that by 1,000, we'll get K ohms. Doggone it. Always want to add an extra digit. Here we go, back to 1,000. That equals 5.65 if we round. We're looking at our answer. It's right here. So let's clear everything and see. 5.65. There we go. Correct answer. All right. So now it's asking for total impedance of this circuit. Now we've got to do a couple of things. We first have to X of L our coil. So we have to find 2 pi FL of that. So X of L, hadn't really been writing this as X of L, but that's really what it is. X of L equals 2 pi FL. So we're going to say 2 times pi times frequency is 250. Notice it's not kilo, it's just plain hertz. Our coil is not in millihenries, it's just plain henries. So again, we're dealing with base units here. Don't have to do anything as far as any conversions or any understanding. We're dealing with just the base units we would normally deal with. So 2 times pi times 250 times 1 equals. So X of L, and I'm going to come back here and erase this so we can put this in, and doggone it, I did that highlighting thing again that I couldn't figure out how to undo while ago. Try it with the mouse. Working. There we go. So let's come up here, we'll erase this, and we're going to write our real value there. We came up with 1.571 ohms. We could write that in K. We may write it in both. So it's 1.571 ohms or 1.57 K ohms. So either one. So we've used this formula. I'm going to get rid of it in case we need this space. And we know R total. Very easy. One single resistor. It's 2K. That's one of the reasons I wanted to have both units in here, is because we're going to be dealing with K, it looks like. So R total equals 2K ohms. Now our formula for ZT, let's see if I can squeeze it in here. ZT equals the square root of R total squared plus x of L squared. So that's our formula. So basically I've got to square this value. Wow, that didn't work well at all. So we can undo that. I've got to square this value, and I've got to square that value, add them together, and then get the square root of that. So let's do that. Let's come over here. I'm going to clear my calculator. I'm going to say, now both of these are in K. I've got 2K and 1.57K, so I'm not going to do anything but use the raw values, the K values, and then I know my answer is in Ks. So R squared, 2 squared plus 1.57 squared equals, then I've got to get the square root of that, 2.54K. And I have an answer here of 2.5K. So if we round down just to a single decimal, it looks like it's this guy. So let's go ahead and touch that and see if it is. And sure enough, we're correct. So let's get rid of this stuff and let's move on. So now we've got the same values. We remember a few of our things here, and that was basically we remember our ZT because it's still on our calculator over there, thankfully. So ZT equaled 2.54 K ohms. And we need ZT in order to calculate IT, because IT is equal to E, which is applied voltage, in this case 5 volts AC, got that right there, divided by 2.54 K ohms. I'll write that kind of underneath here. So this is pretty much Ohm's law, because once we figure out the impedance of this circuit, it is pretty much Ohm's law to get current. So if we do that math over here, and we divide 5 divided by 2.54. Now this is K, so our answer, which is K is 10 to the positive third. Our answer is going to be in 10 to the negative third, which is in milliamps. So I've come up with 1.96 milliamps. That pretty well rounds up to 2 milliamps all day long. And we figure this is the right answer. Some of you may be going, well, how do I know that's really the right answer? Because we came up with an answer of 1.96. How do I know that's milliamps? Again, we can go back to base units. Still got to know how to do your conversions. But remember, it's really 2,540 K. I mean ohms, 2.54 K. K means times 1,000. So let's do it just in base units. 5 divided by 2,540, because I've got to multiply 2.54 times 1,000, because that's what K right here means, equals that. Now I come up with this little bitty number here, and if I need to convert it to milli, I have to multiply by 1,000. So if I multiply times 10, the decimal moves here. If I multiply it by 100, the decimal moves here. If I multiply it by 1,000, it becomes 1.96 milliamps. If I apply rounding, I come up with 2 milliamps, and let's see if that's our answer. And it is. So let's move to the last one. And again, we're going to have to apply some of these same formulas. Now, I don't think is this the same one? 2K, 1 Henry, 2K, 1 Henry, good. So we're building. Remember this was 2 milliamps. And it was 5 volts AC. So this is the same one. So we've got, we're just building on this one problem, which is kind of nice when NIDA does this for us to keep us from having to do that math. Well, if we remember, we know that inside of this thing, 2 milliamps of current were flowing. And it's wanting to know the voltage drop across L1. So we've got an L1 of 1 Henry. So we can't forget our 2 pi FL. Sorry, the calculator disappeared there. Let's clear it out. There we go. Because remember, we've got to use the impedance, the X of L of that. So let me go back to pin mode. X of L equals 2 pi FL. And I know we did this before, but I have forgotten what it was. So we're going to have to do the math here on that coil. So it's 2 times pi times 250 times 1. So the X of L of this guy was 1,571 ohms. So that's right there. 1,571 ohms. Or 1.57 K ohms. Should be coming back to you now. So it's pretty easy to get the voltage drop across this guy. It's basically I times R once we get the impedance. So we have to say I is 2 milliamps. R is 1.57 K ohms. And again, times 1,000 divided by 1,000, they cancel out. I'm free to do just straight math. 2 times 1.57 equals 3.14. That is volts. There's our answer looking at us right there. And there we go. So easy enough. We just got to remember to do this stuff step by step by step and get our answers. And we're done. So as always, if you have any questions, see your instructor. The big thing with doing RL circuits and most other of these formulas is having those formulas and understanding how to apply them. So if you have questions, feel free to ask an instructor. We'll be glad to help you. But hopefully this practice will help you see kind of how to work through these problems.